Okay, so today we are starting probability. We have 2 days of 11.4 and then 2 days of 11.5. Both are going over probability, and then we'll have our test on January 31st. So, probability is the measure of how likely an event is to occur. The set of all possible outcomes is called a sample space. Okay, so for equally likely outcomes, the theoretical probability of an event, written P of E, is the ratio of the favorable outcomes to the total number of possible outcomes. So, okay. So then the next thing we have are simple events. This is the probability of one event. So A says a jar contains 32 red marbles and 28 blue marbles. What's the probability that a randomly selected marble is red? So, I need to first figure out the total number of outcomes possible, so my total number of marbles. How am I going to figure that out? How do I figure out how many total, yeah?
32 plus 28.
Mm-hmm. Okay, so how many total marbles are in the jar? 60. Okay. Then I need to figure out the total number of favorable outcomes. So what's the one I want to get? What color? Red or blue? So I want to figure out the total number of red marbles. How many were in there? So to find my probability of getting a red, so I write this P and then parentheses red on the inside. I take the total number of reds on the top and divide by the total number of marbles. So I want to simplify this fraction. Do you guys remember how to do that? Okay. Divide by what? Yeah, what do they have in common? They actually have 4 in common. So I can divide them both by 4. Which gets me 8 over 15. Or I could have done this on my calculator. Remember, I can go 32 divided by 60. And if I press the math button and then enter, and enter again, it'll simplify that fraction for me. So, the probability of randomly selecting a red marble is 8 out of 15. Or what is that as a percent? Yeah? 53, I'm going to go one more decimal place, so 53.3%. Questions on A? So B says what is the probability of drawing a heart or a club from a standard deck of cards? So first, before I do this, I need to know a little bit about a standard deck of cards. There are a total of 52 cards in a deck. No. Okay. There are 4 suits in a deck: heart, club, spade, and diamond. There are 13 cards in each suit. A deck of cards is half red and half black, so that means there are 26 in each color. So 26 reds and 26 blacks. Okay. So how many total outcomes are possible? How many choices do I have to choose from? 52. And I want to see how many favorable possible I want. So how many hearts are in the deck? There's 13 hearts. And then how many clubs are there in a deck? There's also 13. So, how many total cards do I have to choose from? So the probability of drawing a heart or a club is going to be 26 out of 52. So if I simplify that, what is that? 1/2. 1/2. And what's that as a percent? 50. Questions there? Okay, so before I let you work on the U-try, I just want to tell you, it's asking the probability of rolling a 3 on a die. Remember, on a standard dice, there are 6 sides. And they're numbered 1 through 6. Okay, so today, the next thing we're talking about is the complement of an event. So the complement of an event is the probability of an event not happening. So, since I know all probabilities in a sample space is 1, that's 100% as a decimal. The probability of an event not happening is 1 minus the probability of the event happening. Because it either happens or it doesn't. So C says the probability that it will snow tomorrow is 7 out of 20, or 35%. What's the probability that it will not snow? So, to do this, I'm going to do 1 minus the probability that it will snow. So I'm going to do 1 minus 7 over 20. And I can do this on my calculator. I can do 1 minus, and then 7 divided by 20. And then I want to go math, fraction, to turn it back into a fraction. So this gives me 13 over 20. So there's a 13 out of 20, or what was that as a percent? 65. Yeah. Okay, so question 1, part C. So when it says the word not, you subtract from 1. D says the spinner to the right is spun. Find the probability that it lands on a number that is not prime. So first thing I'm going to do is I want to figure out how many total numbers there are on that wheel. Which numbers are my prime numbers? Prime means it can only be divided by itself in 1. 2. What else?
1.
No, not 1.
4. Right, 1 is either...
Not 4. 3. 5.
7.
No, 9 can be divided by 3. So, no, 15 can be divided by 5 and 3. Okay, so how many numbers did I just circle there in red? 6. So, my probability of being prime is 6 out of 16. So I want to find my probability of not prime. Yeah, so I'm going to do 1 minus 6 out of 16, which is 10 out of 16. I can simplify that though. What is it simplified in?
5 over 8.
Mm-hmm. So there's a 5 out of 8 chance. Or what is 5/8 as a percent? Mm-hmm. Okay, so the last thing we're going to talk about today is experimental probability. And experimental probability is based on repeated trials of a probability experiment. So this is what happens when you actually do it. So, to get your experimental probability, it's the number of successes divided by your number of trials. Okay, so on this one, it says each section of the spinner has the same area. The spinner was spun 20 times. The table shows the results for which color is the experimental probability of stopping on the color the same as the theoretical probability. So, what's my probability of landing on any of these colors? 25% or 1/4. So what I want to do is I want to go ahead and see which of these is going to give me 1/4. So, on red, they did it 5 out of 20 times, because it tells me 5 in the chart, and the 20 is coming from the word problem. What is that as a simplified fraction? What? 1/4? Okay. Then I'm going to do the same thing. Green's below. Green is 9 out of 20. What is that as a simplified fraction? Yeah? 9 over 20. Blue is 3 out of 20. And if I simplify that one? Over 20. And then white is also 3 out of 20. So I know that already simplifies to 3 over 20. So which of those matches my theoretical probability? Yeah, Ben? Red.